Hi everybody, welcome to Lesson 8, Solving Quadratics with Inverse Operations. So far this unit, we've solved by factoring and the zero product property. So far, that's been our only tool for solving quadratic equations. But the past couple of days, we've been working with those irrational numbers. So we're going to learn some other techniques in the rest of this unit where we solve quadratic equations and we get irrational numbers. So the first thing we're going to look at is inverse operations. So before we get to inverse operations, let's solve a couple quadratic equations here. So solve the equations x squared equals 16 and x squared equals 100 by inspection. So just look at it and tell me what the answer is. So what squared gives me 16? That's what I'm asking you. That's what x squared equals 16 means. What squared is 16? And hopefully you recognize that answer is 4. But keep thinking, there's another number squared that gives us 16. What other number squared gives us a positive 16? Happens to be negative 4, right? Negative 4 times negative 4 is actually a positive 16. So x equals 4, x equals negative 4. Same thing for x equals 100. X squared equals 100. X squared equals 100. What squared gives me 100? Well, x could be 10, or what else squared gives me 100? Negative 10. So notice we're getting two solutions here. And the way that I can write that is x equals plus or negative 10. Positive 10 or negative 10 is a way I could write my answer. And over here I could have written x equals plus or minus 4. So this notation of plus or minus is going to come up a lot here on out, where we have the positive number as well as the negative number. Because mathematicians are lazy, so we just smush them together and write it once instead of twice. So let's solve these equations by factoring. So remember, when we solve by factoring, we have a three-step process. The first step is get it equal to 0. Then we have to factor. And the final step is use the zero product property. Set each factor equal to 0. So let's get them equal to 0. Let's subtract 16. X squared minus 16 equals 0. And now I need to factor that. And remember, we have all those good factoring strategies, GCF, trinomial, DOPS. This happens to be a difference of perfect squares here, doesn't it? Where it factors into the factors of x plus 4 and x minus 4. And then using the zero product property, what makes this factor 0? Well, x equals negative 4. Or what makes that factor 0? X equals positive 4. We got the same answers that we got just by looking at that equation. We said it was positive 4 and negative 4. Take a second and pause the video and see if you can solve x squared equals 100 using that same technique by factoring. Get it equal to 0, factor, zero product property. So your answer should look something like x squared minus 100 equals 0, x minus 10, x plus 10 are my factors because it's difference of perfect squares again, equals 0. So you get x equals plus or minus 10 as your two solutions. And finally, one more time, let's solve them by taking square roots. So remember, we can undo squaring. The inverse square rooting is the inverse of squaring. We're going to use this whole idea of inverse operations today. So we have to know this inverse relationship. How do I undo squaring? We take the square root. So if I was solving x squared equals 16, I'm going to take the square root of both sides. Because what that does is it gets rid of the squared. So goodbye, goodbye. We can get rid of those squares in that square root there and gives us x equals, well, what's the square root of 16? 4. But here's where we need a warning, 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 warning. You have to include a positive and a negative solution. Whenever you take the square root, you need to throw a plus or minus in front of your answer. Whenever you take the square root, you need to be throwing a plus or minus in front of your answer. So let's do the same thing to x squared equals 100. How do I undo squaring? I take the square root of both sides. And I get x equals, so what's the square root of 100? 10, positive or negative. So x equals plus or minus 10. Notice we're getting the same answer regardless of what technique we're using to solving it. So using this idea of inverse operations, we can solve it, but there's that one extra warning piece we need to look out for, is that plus or minus needs to get added in. So let's solve this equation by using square roots. Finally, a new equation after solving that same one 3 times there. So x squared equals 20. This is too thin. Let me change my marker for a second. X squared equals 20. So how do I undo squaring? I take the square root. Is 20 a perfect square? What times itself is 20? Some crazy irrational number. So I'm going to leave it. Radical 20. But what goes in front of it? The positive square root of 20 as well as the negative square root of 20. We get both those crazy decimals. A positive crazy decimal and a negative crazy decimal are my solutions. But notice this direction here in simplest radical form. So we've got to take that radical 20 and tear them apart. What two numbers make 20 where we have a perfect square? 4 times 5 is what we looked at on Friday. So radical 4 and radical 5 is really equivalent to 2 square roots of 5. So x equals plus or minus 2 square roots of 5. Notice we got irrational numbers here. We have 2 solutions, but they're both irrational. So that's what we're going to be looking at from here on out, is when we solve quadratic equations, sometimes we're going to get those crazy irrational numbers. So we can solve quadratic equations using inverse operations if x appears once. When we look at equations, x can only show up once. And we're going to use that idea of how can I undo things to solve for x. So let's zoom in here to this one. 2x squared plus 10 equals 28. Here's x. How do I get it alone? How do I undo the things that have happened to that variable x? Well, it's been squared, it's been doubled, and I added 10. So we kind of work on our way back in towards x. We want to undo the most outside peripheral stuff first. So the first thing we're going to do here, actually, we're not going to square root yet, is we're going to subtract that 10 from both sides. 2x squared equals 18. I want to get rid of that x squared, that squared there, but I have that times 2, and I undo that through division. So x squared equals 9. And then when I take the square root, warning, warning, warning. What's going in front of my answer here? A positive or a negative 3. I could only use this idea of inverse operations because I saw x once. It wasn't a trinomial like we've been solving where x pops up multiple times. I saw x once. So that's how I knew I could use this idea of inverse operations. All right, here's x. How do I get him by itself? Well, that 5 has nothing to do with it, so I'm going to add 5 to both sides. So x squared over 2 equals 8. Times 2 times 2. Why did I multiply by 2? To undo that division there. X squared equals 16. Well, if I square root both sides, that leaves me with x equals, so what's the square root of 16? 4, but I took the square root, so that means I have a positive solution as well as a negative solution. So I like solving using inverse operations. It's a lot quicker than factoring because it's kind of methodical. There's not a lot of thinking of what multiplies to this and adds to that. You just have to go through and realize, all right, I've got this operation. How do I undo it? Tempting to do, it's really tempting to add 2 to both sides, but you can't do that because it's trapped inside that squared there. So our first step is actually going to be to get rid of that squared. So I'm going to take the square root of both sides. That gets rid of the squared for me. So x minus 2, well, what's the square root of 25? 5, but I'm going to put a plus or minus in front of it. And now we're going to be running into things that look like this a lot. How do I get rid of x that negative 2 from my x? I'm going to add it. And when I add it, I'm just going to stick it right in front of that plus or minus. 2 plus or minus 5. I'm going to add that 2 right in front of the plus or minus. And now I'm going to actually figure out what my answers are. What are 2 plus 5? So that gives me x equals 7. 2 minus 5. That gives me x equals negative 3. Those are my two solutions. So notice, I saw x once, so I started doing inverse operations, and I landed with 7 and negative 3. All right, if you can do this one, you can do any of them. I need to start on the outside and work my way in. So I see that minus 50 there just hanging out. I'm going to add 50 to both sides. Now, I know it's so tempting because your math teacher has been telling you this since 7th grade. Distribute, distribute, distribute. You cannot distribute here because if we follow the order of operations, exponents come before multiplication. So that 2 can't get distributed in there because of that squared. So I need to get rid of that 2 through division. I know it's tempting to distribute it, but you can't distribute because of that squared term. So x plus 5 squared equals 100. How do I undo squaring? I take the square root. X plus 5 equals 10, but a plus or minus in front of that. I'm going to subtract over the 5. Negative 5, remember it goes right in the front there, plus or minus 10. So let's see what we get here. Negative 5 plus 10 is positive 5. Negative 5 minus 10 is negative 15. Those are my two solutions to that quadratic equation. So notice all these equations actually came out to have rational number solutions. So that means I could have factored them if I cleaned them up a lot. But notice when it's kind of nice and brings us back to solving linear equations is by using this idea of inverse operations. The key new inverse here is how do I undo squaring? I take the square root, but it actually gives me two different answers. It gives me a positive as well as a negative. Let's play around with some irrational numbers right now. Actually, not yet. Let's quickly talk about this one. Can we solve this using inverse operations? X plus 4 squared equals 2x plus 32. Well, it looks tempting. It looks tempting. It looks like I could just square root both sides. And that'll get rid of the squared for me. But look right here. How many x's do you see? More than one. You cannot use inverse. We cannot use inverse operations. Why can't we use inverse operations? X appears more than once. X appears more than once. Our only option at this point would be to clean up both sides, set it equal to 0, factor, zero product property. So you could solve this equation that way. You cannot use inverse operations because X appears more than once. Now we get to the fun ones. Solve each of these equations using inverse operations. Express your answer in simplest radical form. So that means we need to break apart square roots, break apart irrational numbers. We need to break apart the square roots using perfect squares. First thing I'm going to do here, I think, is add 2. So 5x squared equals 40. I don't want 5x squared. I'm going to divide by 5. X squared equals 8. Well, 8's not a perfect square, so when I take the square root, I'm going to get some irrational number. I'm going to get some irrational numbers, positive radical 8 and negative radical 8. I took the square root, so I have to include that plus or minus. Okay, well, let's go over here to Scrapland. How do I deal with the radical 8? What perfect square divides into 8? Well, 4 does. 4 times 2 is 8. So I actually get 2 radical 2. So my final answer here is x equals positive or negative 2 radical 2. I have 2 different answers. 2 square roots of 2, negative 2 square roots of 2. Those are my 2 answers. All right, I see x1s, which means I can use inverse operations. And I'm going to start by subtracting 10. X minus 3 squared equals 28. How do I undo squaring? I undo squaring by taking the square root. So x minus 3 is plus or minus radical 28. We'll break that down at the end because we're basically done at this point. How do I get x by itself? I add that 3 over. I'm going to add that 3 over and just stick it right in the front. I'm going to stick it right in the front there. X equals 3 plus or minus radical 28. So we're done. We're done solving the quadratic equation, but it said simplest radical form. So let's tear apart 28. What perfect square, 1, 4, 9, 16, 25, which of those numbers divides into 28? Well, I think it's 4 times 7. So 2 radical 7. So my final answer, x equals 3 plus or minus 2 radical 7. That is a beautiful irrational, two beautiful irrational numbers. 3 plus 2 radical 7, 3 minus 2 radical 7. They're crazy decimals, but those are my answers. You're looking at this right now and being like, there's a 1/2 there, I can't do this problem. Well, we've done this before. How do I get rid of a 1/2? I double everybody. 0 equals, that gets rid of the 1/2, x squared minus 12. Make your life easier, and if you see a fraction, remember, you can always multiply, use the multiplication property of equality to multiply by the denominator to get rid of that denominator. I'm going to add 12. 12 equals x squared. And I undo squaring by square rooting, so plus or minus the square root of 12 is x. We're done. We're done solving, but now we got to play the break apart game. How can I break apart the square root of 12? I can break apart the square root of 12 as 4 times 3. That one's not too bad to do. 2 radical 3. Why couldn't I use 6 and 2? 6 and 2, neither of those two factors are perfect squares. We have to find a perfect square factor of that number. In this case, it was 4. So my final answer is plus or minus 2 square roots of 3. It's the same numbers, they just look different. I changed the way those numbers look. Slide in. Pause the video at this point. I've done 3 for you. Pause the video right now and try to solve this one on your own. When you're done solving it, hit play and see if it matches your solution. Hopefully you actually did that and just didn't let that awkward silence of a pause go by. I'm going to add 20. Then I square root it to get rid of the squared. X plus 4 equals, I hope you remembered that plus or minus because I've only been talking about it for this entire video. And then I'm going to subtract over that 4. Negative 4 plus or minus the square root of 20 are our two solutions. There's a positive version and a negative version. But let's go over here to Scrapland and break apart 20. What perfect square divides into 20? I think for the 4th out of 4th time, it's 4 again. 2 radical 5. So my final answer, and hopefully your final answer, was negative 4 plus or minus 2 radical 5. Remember, you cannot add those two integer values because that 2 has that square root attached to him. We're going to skip over 6. Let's go right to 7, and then we'll end this video with 7. Does this equation have any real solutions? So we're going to talk about sometimes when you solve quadratic equations, bad things can happen. And we're going to talk about one of those bad things right now. So I'm going to use inverse operations. I'm going to subtract over that 3. X minus 1 squared equals negative 3. I'm going to square root both sides and get x minus 1 equals plus or minus the square root of negative 3. But we have a big problem on our hands right now, and it's this thing right here. What times itself equals negative 3? Well, it's not a rational number to start with, but anything times itself, two positive numbers always make another positive number. Two negative numbers always makes another negative number as well. So the only way to get a negative number is one would have to be positive and one would have to be negative, but that means I'm not dealing with the same number. So the square root of -3, it's not a real number. That we can't have that in our number system we've developed. So this is not a real number. And at this point, we quit. We're not going to deal with these things in Algebra 1. It comes back in Algebra 2 because it's twice the fun. So we're going to quit at this point and say, you know what? You cannot have the square root of a negative number. The square root of a negative number is not real. It is not a real number. Yes, it's imaginary. I'm being serious. That's what we call it later on. But it's not a real number. We quit. So are there any real solutions? No. There are no real solutions because of that negative inside the square root. So at this point, I'm going to stop this video. I think I have, not 6. There's 9. Try your best on these 9. I'll have the answers online, and you can check them when you're done.